All right, so let's start the second part of the problem solving for chapter 2. So today we basically work on free fall problem. Okay, free fall problem and probably one problem on graphical representation of linear motion. Okay, all right. So before we start this problem, let me briefly review what we learned in free fall and then solve this problem. Okay. All right. So to solve the free fall problem, the first thing we need is the kinematic equation. Okay. So the kinematic equation, let me write down here. Okay. So here are the kinematic equation. Okay. So x equal to x0 plus vt, and then v equal to v0 plus at, x equal to x0 plus v0t plus half at square, and then the last one is this. Okay, now as the free fall means the object falling either downward, or when you throw something up it will probably go upward. So the free fall problem, all free fall problems are basically the problem where object moves up and down vertically. Okay, so so um, let's modify this equation, okay, to represent the vertical motion. So normally vertical axis is y, so we don't need basically this one, so we need basically these three equations for most of the problem in free fall. So let me write down this. So v equal to v0 plus at, okay, and then y equal to y0 plus v0t plus half at square, and then v square equal to v0 square plus 2a y minus y0. Okay, so here I just replace x by y. Okay, so let me erase this. Okay, the first set of kinematic equation, because the free fall always along the y direction, so I just replace x by y. Okay, the next thing we have to understand is when you throw something up or when you drop something down, okay, if you neglect the air resistance, so normally in all the problem in free fall section we are going to ignore the air resistance. Okay, even if I do not write down that ignore the air resistance, for example here I wrote down ignore the air resistance, in some of the problem maybe I do not write this, but even though you can ignore the air resistance. So problem in chapter 2 and chapter 3 we are going to ignore the air resistance. Okay, so when we ignore the air resistance, the only thing that affects the object's motion is the gravity. Okay, so the only thing that affects the object motion is gravity. Okay, so gravity is related to the gravitational acceleration, and that is the value of gravitational acceleration is 9.80 meter per second square. Okay, and as you know that gravity is always downward. I mean, when you drop something it goes downward because earth pulls everything downward, or if you throw something up it comes down because again earth pulls everything downward. Okay, so the direction of the gravity is downward, that you have to remember. Okay, so in this, I mean in all these free fall problem there is only acceleration, and that is the gravitational acceleration. Okay, no matter which part of the free fall you are free fall of an object you are talking about, always its acceleration is this 9.80 meter per second square, and it is always downward. Okay, so this thing you're supposed to remember. Okay, so if you remember this, with this new information we can modify this equation as this. Okay, so here A is replaced by gravitational acceleration, and then there is a negative sign. A is replaced by gravitational acceleration and a negative sign. A is replaced by gravitational acceleration and a negative sign in front of all the gravitational acceleration. So here you see how I modified the kinematic equation for free fall. So once you have this, then you are ready to solve the free fall problem. Okay, so let's try to solve our first problem on free fall. Okay, so this is the first problem. All right, so what it asks us to calculate. Suppose that a ball is dropped. So when we drop something, that times the initial velocity is equal to 0. Okay, so remember this information. When you drop something, that means the initial velocity is 0. Okay, so we drop this ball from a tower that is 70-meter high. Okay, and it said that how far will it have fallen at time t1 equal to 1 second, t2 equal to 2 seconds, and t3 equal to 3 seconds. So first thing we have to calculate is the distance, vertical distance in 1 second, 2 seconds, and 3 seconds. And then number 2 says that what are the corresponding velocities at time t1 equal to 1 second, 2 seconds, and 3 seconds. Ignore the air resistance. Okay, all right. So when we, okay, let me draw the situation. Okay, so let's say this is the tall tower, 70-meter long tower. So the ball is dropped from this point. Okay, so ball is dropped from this point. Okay, now we can think that this is our initial position, initial vertical position. So we can think that y0 equal to 0. Okay, now in a coordinate system, okay, so let's say this is the coordinate system, this is y and this is x. Okay, so if this is 0, okay, if this is 0, all the point above this are positive, all the point below this is negative. Okay, so remember that we may need this information. Now when you drop something, you see that the ball will go in this direction. Let's say in 1 second it is somewhere here. So because it is below 0, below the initial position, right? So we are expecting here y1 equal to some negative distance. Similarly, y2 some negative distance. Okay, y3 some negative distance. Okay, y1 means the distance it travels in 1 second, distance y2 means the distance it travels in 2 seconds, and so on. Okay, we also want to know what is v1, the velocity. Okay, what is v2 and what is v3. Okay, all right. Now you see that if I want to calculate y1, we need this equation. I mean y1, y2, or y3. For all these, we need this. Okay. And for v1, we probably need this one, the first equation. Okay. So let's see. Let me use another color so that we don't mix up. So let's start with this one, y1 equal to y0 plus v0t minus half gt square. So for y1 it will be t1 and then it will be t1. Okay, now you see that y0 equal to 0. Okay, the initial position is equal to 0, and when we dropped something, then v0 is also equal to 0. Okay, so this is also equal to 0. So the equation is very simple now. Okay, that is equal to that is equal to minus half g t1 square. Okay, now the value of gravitational acceleration is 9.8 and t1 is basically 1. So what we get here is minus 4.90 meter. Okay, so this is 4.90 meter. All right. Now, how about T2? T2 means when T equal to 2 seconds. Okay. So for the T2, the equation will be, okay, so for T2, the equation will be this. Okay. Again, this is 0, this is 0. Okay. So the equation is very simple. Minus half G T2 square. Okay. And T2 means time equal to 2 seconds. Okay. So if you plug the value T equal to 2 seconds, okay, then you can show that Y2 is equal to 19.6 meter. So Y2 is negative 19.6 meter. Okay. Similarly, similarly for 3, this will be 3, this will be 3, this will be 3, this will be 3. So T3 means time equal to 3 seconds. Okay. So again, if you plug the value of gravitational acceleration and time T3 equal to 3 seconds, okay, then you can show that the time is equal, the distance at 3 seconds is equal to 44.1 meter. Okay. So many students here forget the square. So this is square. So make sure you don't forget it. Okay. So if you don't square the number, so here the number is 3 seconds. Okay. So T3 equal to 3 seconds. So you have to square it and then multiply by the gravitational acceleration and then divide by 2. Okay. So if you forget that square, you may get the incorrect answer. Okay. I mean, you will get incorrect answer. So make sure you square the time. So the Y3 we get minus 44.1 meter. Okay, and that all makes sense. All right. Now the corresponding velocities. Okay, so corresponding velocities, we have to use the first equation here. The first equation is V1 equal to V0 minus GT1. So V0 is 0 because the initial velocity is equal to 0. Okay, so V1 is basically GT1. Okay, so it will be basically minus 9.80 meter per second. Okay, so T1 equal to 1 second. Similarly, V2 equal to minus GT2, and when you plug the value of T2 here, you should get something like this, 19.6 meter per second. And similarly, V3 equal to minus GT3, and that is equal to when you plug the value of the gravitational acceleration and T3 equal to 3 seconds, you should get something like this, 29.4 meter per second. So the result is here 9.80 meter per second, here minus 19.6 meter per second, and here it is 29.4 meter per second. Okay. All right. And the velocities are negative because it is going in the negative direction. Okay. So down means negative, right? Up means positive in the y direction and down means negative. So it makes sense. So we are getting negative value and that makes completely sense. Okay. All right. Let's move on now for the next problem. Okay, so let me keep this three equation. Maybe we need to use this three equation in the next problem. Okay. All right, now suppose the ball in the previous problem is thrown downward with initial velocity. Okay, so in the last problem V0 was 0. Okay, so in the last problem we just dropped the ball. Okay, with initial velocity was equal to 0. Now here we have to we have some initial velocity that is equal to 3 meter per second. Okay, so we drop the ball at initial velocity that is equal to 3 meter per second. Okay, now we have to do the same thing. We have to find y1 and y2 and also the v1 and v2. Okay, but here it asks us to calculate the speed. Okay, so in the last problem it asks us to calculate velocity. Okay, so what are the corresponding velocities? Okay, okay, and then here in the next problem it asks us to calculate the speed. Okay, so we have to be little bit careful. Okay, speed is always positive. Okay, because the distance, if you remember, the speed is related to distance, and distance is always positive. Okay, so and the time. Okay, so because the speed is positive, so we have to be careful. So I will show you. Okay, but yeah, remember that speed is always a positive quantity because it does not depend on the direction. Okay, it is different than velocity, but they are somehow related. Okay, now to solve this problem we start with the same strategy that we use in number 10, and then once we have the velocities we can convert that velocity in speed. Okay, all right, so here we want to know what is the y1 and y2. Okay, so when t is equal to 1 second and t is equal to 2 seconds. Okay, okay, so position y1 is equal to y0 plus v0 t minus half g t square, and again y0 is equal to 0 because the initial position is always 0. So y1 equal to v0 t minus half g t square. This is the equation. Okay, now v0 for this problem is 3 meter per second. Okay, now again here we have to careful, so this is little bit tricky. Okay, so this is y is in this direction, so we drop, we throw the ball from this position. Okay, from y0 equal to 0 position, right? When you drop something below this line, below y0 equal to 0, the position, all the position y1, y2, y3, all those things will be negative. Okay, and also the corresponding velocities will be negative. Okay, why? Because they are going downward. Okay, downward means negative direction, so as they are going negative, as they are going in the negative direction, velocity will also be negative. Okay, so now here it says that the initial velocity is 3 meter per second, but it didn't tell you that whether you have to use a negative sign or positive sign. It's your responsibility to understand that because it is going downward, the downward direction means negative direction in our convention. So the v0, okay, v0 is minus 3 meter per second. That we have to substitute. Okay, so that we have to understand. So v0 is not just 3 meter per second, it's minus 3 meter per second, because when you throw something downward, it goes downward, and because downward is negative in our convention, so v0 will be minus 3 meter per second. Okay, so once you know that, then the rest of the thing are easy. Okay, so this is 3 meter per second, and then 1 second minus half 9 meter per second square, and then 1 second square. Okay, so minus 3 times 1, and then minus half, 9.8. So if you do this math in your calculator, you should get y1 equal to minus 7.90 meter. Okay, and it is different than last time. Okay, so last time it was 4.90. Now you see that it's travel 3 meter more. Okay, because it already started from 3. Okay, I mean, the speed is basically, I mean, what I mean is the speed in the last problem, the speed was 0, but in this problem, the initial speed is equal to 3 meter per second. So the position of the ball at 1 second is minus 7.90. Okay. Similarly, you can show that y2 equal to v0. So here it is t1. Okay. Here we have t2. Okay, t2 means time t2 equal to 2 seconds, and if you plug the value similarly, okay, v0 equal to minus 3, t2 equal to 2 seconds, gravitational acceleration is 9.80 meter per second square, and t2 again is 2 seconds, then you should get something like this. I got minus 25.6 meter. Okay, which is again higher than the last problem. Okay, in the last problem you got y2 equal to minus 19.6. Here you get minus 25.6 meter. Okay, all right. All right, so that is the first problem, I mean number A. So y1 equal to minus 7.90 meter and y2 equal to minus 25.6 meter. Okay, so that's the position of the ball at t equal to 1 second and t equal to 2 seconds respectively. Now the next thing is, what would its speed be after 1 second and 2 seconds? Okay, so let's calculate this. Okay, so again, for speed we will be using the first equation. Okay, similar to the problem number 10, but again here we have to be careful about the initial velocity. Okay, so v1 will be v0 minus gravitational acceleration t1. Okay, so here v1 is the velocity at t equal to 1 second. Okay, okay, so what we get is something like this, minus 12.8 meter per second. Okay, it is higher than what we see in the last problem. Okay, in the last problem it was 9.8 meter per second. Okay, now it is minus 12.8 meter per second. Okay, now this is the velocity v1, and similarly you can show that v2 equal to v0 minus gravitational acceleration times t2. v0 is again minus 3 meter per second. The gravitational acceleration is 9.8 meter per second square. T2 is 2 seconds. So if you plug all this value correctly, you should get something like this, minus 22.6 meter per second. Okay, and again it is higher than the v1 in the last problem, I mean v2 in the last problem. Okay, now these are the velocities. So what would be the speed? Speed when objects are moving in a straight line. Okay, and if they don't change, okay, if they don't change the direction in their journey, then here is a trick to calculate speed from the velocity. Okay, so here is the trick to calculate the speed from velocity. Speed is the absolute value of the velocity. Okay, absolute means whatever the value, it will be always positive. Okay, so here in this problem, or in the last problem, if I want to know what is the speed instead of velocity, so I would just take the absolute value. So for example, the absolute value of this number is 12.8 meter per second. The absolute value of this number is 22.6 meter per second. Okay, so if I want to know what is the speed instead of velocity, it will be this. Okay, and this is only valid when object moves in a straight line and it doesn't change the direction in its journey. So for example, when you drop something, it's just going downward, right? It doesn't change the direction in its direction of its path. Okay, so we can do that, but if it change the direction and if it is not in the straight line, we cannot do that. So the trick is, if the object is moving downward, okay, or upward in a straight line, okay, of course when it is moving in upward and downward, it's in straight line, but if it does not change the direction, okay, if it is going upward, then we can do, if it is just keep going in upward, or if it is going downward, if it is if it is going in downward and keep going in the downward, then we can do that. So in that case, the speed is basically the absolute value of the velocity. What it means if you get positive sign, then speed and velocity is basically the same thing. But if you get the negative sign for the velocity, the speed will be just the positive of that value. Okay, that is the absolute value. Okay, all right, and the same thing for the position. Okay, so if I want to know the distance from the position, okay, we can do the same thing. For example, in this problem, we got y1 equal to if I remember correctly, it was something like this, 0.7.90 meter. So this is the position at t equal to 1 second. If I want to know what is the distance, okay, then it is just the absolute value of this value. So it will be 7.90. So the ball travel 7.90 meter in 1 second. Okay, so again, we can do that if the object is moving in a straight line and it doesn't change the direction in its journey, okay, during its journey. Okay, then the distance is basically the absolute value of the position, and speed is the absolute value of velocity. Okay, remember that. So here, as it asks us to calculate the speed, we have to just present the absolute value of the velocity. Okay, all right, let's move on. All right. All right. So here, in the last two problem, we either drop an object or throw an object downward. Okay. Now this time, this lady is throwing an object upward. Okay. So even she's throwing an object upward, it's under free fall. Okay. Why? Because when she throw an object upward, it goes up, and at some point it stops and come back. Okay, and it is again due to the gravity. Okay, so if you ignore the resistance, ignore the resistance due to the air, or ignore the air resistance, it's basically the gravity that can affect the motion of this object. Okay, so even she's throwing the object upward, this is again a free fall problem. Okay, so what we are given here, okay, so she is throwing an object with an initial velocity 15 meter per second upward. So at the point A, okay, at this point, the velocity, initial velocity was 15 meter per second. Okay, so that is the only information we are given here, and it says how high it goes. Okay, so you know that as you throw something up, it goes up, 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 and then at some point it come down, right? So what happened here? So when you throw something up, it goes up, and as it is going up, its velocity is decreasing. Okay, why velocity is decreasing? Because the gravity is always downward, right? Gravity is always downward. No matter where the object is, the gravity is always downward. So the gravity is downward, and when you throw the object up, it is working against gravity, right? So gravity is in this direction and velocity is in this direction, so the object slows down. Okay, so it slows down, and at some point it will stop. So at the maximum height, the object velocity will be 0. Okay, so this maximum height we also call apex. It has some name. The maximum height means also we called apex, and at apex or at maximum height, the final velocity is equal to 0. So when you throw something up at its maximum height, the velocity will be 0, v equal to 0. So now we have several information with this. Okay, although it's not explicitly written that at maximum height v equal to 0, you have to understand that at maximum height v equal to 0, the final velocity should be equal to 0. Okay, so because now we have this information, v0 equal to 15 meter per second, v equal to 0, gravity equal to gravity equal to 9.80 meter per second square, and we have to calculate how high it goes. That means y equal to what. Okay, so with this information, I think this is the no, not this one. The last equation is useful. So the last equation was v square equal to v0 square minus 2g y minus y0. Oh, okay, so here y0 you can use y0 equal to 0. I mean, what I mean is at this point you can think that y0 equal to 0. So that your initial position, your reference point here is y0 equal to 0. Okay, so with that, let's plug the values and see that what we get. Okay, so 0, v0 square minus 2zy. So if I solve it, I get this. So y equal to v0 square 2g, 2 gravitational acceleration, 2 times the gravitational acceleration. So if I plug the value 15 square and then 2 times 9.80, okay, it should give me something like this, 11.5 meter. Okay, so the object will go 11.5 meter up. Okay, so how high it goes? It goes 11.5 meter. Okay, all right. So once we have it, the next thing is how long the ball is in air before it comes back to the hand. Okay, now let's erase this and see what we are given for the next problem. Okay, all right, for the next problem, again v0 is this one, that's correct. This is not correct. Okay, now this is not correct in that sense, because the object goes up and then come back. Okay, so the only information here we are given is v0 equal to this. The gravity is 9.8 meter per second square, and then y0 is equal to 0, and y is also equal to 0, right? So you see that y's a and c are basically the same position. Okay, so because it comes back to the hand, y and y0 both equal to 0. Okay, that are the given information. Okay, and then what is the time? Okay, what is the time? Okay, what is the time? Now, so the time, what is the time? The object is in air. So you see that when you throw it up, it goes up and then come down. Okay, so the time we have to calculate is when you throw it up and when you catch it. Okay, so with this information, the equation you can use to solve t is this one: y equal to y0 plus v0 t minus half g t square. Okay, this is the only equation. Here you see that you know y, you know y0, you know v0, you know gravitational acceleration, you do not know t. So that's actually a good equation, okay, to solve this problem and to solve number B. So here y equal to 0, y0 equal to 0, so v0 t minus half gt square. Okay, now let's solve this equation for t. So half gt square equal to v0 t. So what we have here, gt, okay, half gt equal to v0. So t equal to, so here I can cancel one of the t. Okay, so in the left hand side I have half g times t, and if I cancel t with the left hand side, here we should have only v0. So then if you solve it for t, you get 2v0 over the gravitational acceleration. Now 2 times 15, and then gravitational acceleration is 9.80. So if you do this math in your calculator, you should get 3.06 second. Okay, so the time the object, the ball, will be in air is 3.06 second. Okay, all right. Now, if we understand this, the next thing is how much time it takes for the ball to reach the maximum height. Okay, so this time, the time we just calculated is the total time. Okay, starting from the starting position to the end position. Okay, so when you throw and when you catch, this is the total time. Okay, so and total time is 3.06. Okay, and if you ignore the air resistance, okay, this time is equal to the time it takes to go from A to position B plus from position B to from position C. From position B to position C. Okay, so the total time, this 3.06, is the time it takes to go from A to B plus B to C. Okay, now if the air resistance is negligible, or if you ignore the air resistance, this time is basically the time it takes to go from A to B will be half of the total time. Okay, so 3.06, and from B to C it will take the other half. Okay, so from A to B it will then be 1.53 second, and from V to C it will take another 1.53 second. Okay, so that's the beauty of a free fall problem. Okay, so when you ignore the air resistance, of course here we are ignoring the total time, it takes to go from position A to position C is 3.06. Now, if I want to know what is the what is the time it takes to go from A to B, it will be just half of 3.06. Okay, and that is 1.53 second. Okay, now so that's the conceptually how we can solve it, but let's prove it. Okay, so let's erase. So there are several ways to solve this. Okay, you can, for number C, you can use this equation. I mean, all of the equation we have, you can use now. So that is the simplest one. This equation is the simplest one. Okay, so we are trying to calculate the time it takes to go from A to B. Okay, now when the object is at A, the initial velocity is this. Okay, when the object is at B, the final velocity is 0, and this is this, right? So T is equal to 15 meter per second divided by the gravitational acceleration, and it is exactly equal to 1.53 second that we calculated from conceptually. Okay, so either you can, I mean, if we have this problem, either you can solve it conceptually or by using any of the kinematic equation for free fall. Okay, all right. The last problem is the velocity of the ball when it returns to the lady's hand. Okay, so let's now calculate it. Okay, so we have to calculate the final velocity v equal to 0. V equal to what? When it is coming to the lady's hand. Okay, so when she catch it, what is the ball's velocity? Okay, now what we are given v0 equal to 15 meter per second, and gravity we already know 9.8 meter per second square. Okay, okay, now T. Okay, so again there are several ways to solve this problem. Okay, so I will be using this equation, v equal to v0 minus gt. Okay, now here v0 is this 15 meter per second, that is the initial velocity. But what is the t? Here t is the time it takes to go from A to point C. Okay, so we have to be careful that t is not 1.53 second here. T is 3.06 second. That is the total time, because now here initial velocity we are using 15 meter per second. Okay, so 15 meter per second is the object's or the ball's velocity at point A. Okay, now we want to know what is the velocity at C. So before it coming to C, it travels A to B and then B to C, right? And the time it takes is equal to 3.06 second, and that we calculated in problem number B. Okay, so we have to borrow some information from problem B. Okay, so this is from B. So if we plug this value now, you will see that the velocity is very close to 15 meter per second. Okay, but it is negative. Okay, remember that it is negative, because when you catch the ball, it is basically before it hitting your hand, I mean before it hits the lady's hand, it is going downward, right? Because it is going downward, the direction should be negative. And how we get the negative direction? By getting a negative sign. Okay, so because it is going downward, we should have a negative sign, and as we get a negative sign here, it makes sense. Okay, so the velocity when it hits this person's hand is negative 15 meter per second. All right. All right. Two more problem in this chapter. Okay, so here this is basically a typo, so yeah, so ignore it. All right, so the next problem is this one. Okay, so what it say? So it says that suppose that the person of the previous problem is basically the continuation of the last problem. Okay, suppose that the person of the previous problem is standing on the edge of a cliff so that the ball can fall to the base of the cliff that is 50 meters below as shown in the figure. Okay, so the cliff is 50 meters tall. Okay, now it tells us to calculate the time. Okay, so time means the point she throws it up to the point it hits the base of the cliff. Okay, so this time we have to calculate. So the time, basically the travel time of this dotted line we have to calculate. Okay, now what we are given here, we are given that this point when she throw this up, right, we can think that that position is equal to 0. The as it is the continuation of the last problem, we can also think that v0 equal to 15 meter per second. The initial velocity is 15 meter per second. Okay, and then gravity is 9.80 meter per second square. Okay, and final position, so if this is y equal to 0, all position below this is negative, right? So as the height of the cliff is 50 meter, okay, so from here to here is 50 meter, but because it is below y equal to 0 line, so our y here is negative 50 meter. Okay, so here you see that y equal to negative 50 meter. So negative 50 meter, by negative 50 meter we mean that this is below our 0 line. Okay, below our y0 equal to 0 point. Okay, because it is below the initial position, that's why we have negative sign. Okay, so this is basically the convention of the coordinate system. Okay, so remember that if you use a positive sign, you get an incorrect answer. So we have to calculate this. So the equation, if you compare this known and unknown quantities with the kinematic equation, you will see that this equation is useful to solve this problem. Okay, this is the equation that we need to solve this problem. So y0 equal to 0, so erase it. Okay, so this is the equation. Okay, now let's plug the value and then solve it. Okay, so if we plug this value, we get minus 50 here, and v0 t, v0 is 15. Okay, t is just t, and minus half 9.80 t square. Okay, so if you plug this value, the equation becomes this. Okay, now let me erase this because I need more space. So what we get here is minus 50 equal to 15t, and then minus, if I divide 9.8 by 2, it gives me 4.90 t square. Okay, Now it looks like a quadratic equation. Okay, so let me rewrite this quadratic equation as this. Okay, let me take all the quantities, all the terms in the left hand side. Okay, so we get something like this. Okay, now this is a quadratic equation, and this looks like a t square plus bt plus c, okay, equal to 0. And in math class, you already learned that if we have an equation something like this, the solution of these equations, will be something like this: t equal to 2 times a, okay, and then minus b plus minus square root b square minus 4a times c. Okay, so this would be the solution. And here you see that we have two solutions, one for positive, one for negative here in this. Okay, all right. Now if we compare this equation with this equation, okay, t will be something like this. T, for our problem, t will be something like this: 2, a is here 4.90, okay. Now minus b is minus 15, okay, b is minus 15, and then plus minus b is minus 15 square minus 4, a is 4.90, and c is minus 50. Okay, so this is the solution. Okay, now so if you do all the terms correctly, all the math correctly, you should get something like this: 9.80, here 15 plus minus, and that will be 1205. Okay, and then you will have two number, one for positive here and one for negative here. So if you do all the things correctly, you should get okay, so let me do one more line. So 15 plus minus 34.7 divided by 9.8. Okay, and let me erase this. Okay, so the two equation we get are something like this: 5.07 second for the positive sign, and for the negative sign we get something like this: minus 2.01 second. Okay, so quadratic equation should have two solutions, and we got two solutions, and that makes sense. But one of the solution is negative, right? And time in our universe cannot be negative, right? So this is a unphysical time. Okay, so it cannot be our solution. So the only solution we can have is t equal to 5.07 second. So the time it requires to go from this, from the point when she threw it upward, and this point, okay, the time it takes to go from here to here is 5.07 second. All right, so here we have to solve a quadratic equation. Make sure you understand how to solve a quadratic equation. Okay, all right. The last part of this problem is okay, what is the total distance traveled by the ball? Okay, so what is the total distance the ball travels? Now you can solve it by using the given information and one of the kinematic equation, but here it's basically simple. Why it is simple? In the last problem, you see that you already calculated that the distance from here to here is 11.5 meter. Okay, so, in the last problem, let me go back. Okay, so one of the problem was how high it goes, right? So from here to here it is 11.5 meter. Okay, and it also tells us that from point B to C also 11.5 meter. Okay, so the total distance the ball travels is 11 point okay, so 11.5 meter plus 11.5 meters. So 11.5 meter it goes up, and then 11.5 meter it come down, plus 50 meter. Okay, so this is the total distance the ball travels. So here we are only interested on distance, so we don't care about the sign. Okay, so we are basically caring about the absolute value. Okay, so 11.15 meter up, and then plus 11.15 meter down, and then 50 meter to the base of the cliff. Okay, so the total is 73 meters. Okay, so the total distance the ball travels is 73 meters. Okay, so here we just use the known information, okay, from the last problem and this problem, but we can also solve this problem by using one of the kinematic equation. Okay, but let's use the simplest thing. Okay, all right, the last problem in this chapter is about the graphical representation of the linear motion. Okay, and let's say this is the graphical representation of one of the one of the motion. Okay, so here a bicyclist has the position versus time graph shown in the figure. So it's basically the position versus time graph. And if you remember from the theory, the slope of a position versus time graph is velocity. Okay, so when we have a position versus time graph, okay, the slope is basically delta x delta t. Okay, so here you see the rise is x and run is t. So this is rise and this is run. Okay, so rise means delta x, okay, and run means delta t, the change in time and change in position. Okay, and this is the slope. And if you remember from the definition of the velocity, it is the velocity. Okay, so if we have a position versus time graph, the slope basically tells you about the velocity. On the other hand, if we have a velocity versus time graph, okay, the slope of velocity versus time graph is acceleration. Okay, although I don't have I didn't set a problem about acceleration, but the thing is very similar. Okay, all right, now let's try to calculate what it asks us to calculate. Okay, so what is the bicyclist velocity at t equal to 10 second, t equal to 25 second, and t equal to 35 second. Okay, so t equal to 10 second is this. Okay, so if I want to know what is the velocity at t equal to 10 second, we have to find the slope of this line. Okay, so how to find the slope? The first slope will be, okay, delta x delta t. Delta x is x2 minus x1, t2 minus t1. So what we have to do, we have to find 2 points. So for example, let's 2 points in this graph, in this line. So let me choose this one, and that is x2 and t2, and this one as x1 T1. Okay, so the corresponding value on the vertical axis is x2. So here x2 is 100, and corresponding value for this point in the vertical axis is x1, so it is 50 meter. Okay, and this is T2, so 20 minus this is T1, so 0. So what we get here, 50 divided by 20, so that is 2.5 meter per second. So this is the velocity v1 at T1. Okay, 2.5 meter per second. All right, now the next one is what is the velocity at time t equal to 25 seconds. So 25 seconds is somewhere here. Okay, so what we have to do, we have to calculate the slope of this line. Okay, so we have to calculate the slope for this line, that is v2. But because this is parallel to the run, so when a line is parallel to the run, then the slope is 0. Okay, so v2 will be 0 meter per second. Why? You can also use the equation. So v2 will be delta x delta t, x2 minus x1, t2 minus t1. So this is x2 t, sorry. So in this line, I will be choosing this as x2 t2, and this is x1 t1. So for both for x1 and x2, the value is 100. So 100 minus 100 is 0. So whatever the value in the denominator, it doesn't matter, because x2 minus x1 is 0. So v2 is 0 meter per second. Okay, so the velocity is 0 for the second problem. Okay, when the time is 25 seconds, the velocity equal to 0 meter per second. Okay, so that means there is no change in position. Okay, so at this point, basically the car or the bike, here the bicycle, so the bike is basically at rest. Okay, because v equal to 0, that means the bike is not moving. Okay, and then the 35 second is somewhere here. So we have to calculate the slope for the third line. So let's try. Let me erase this and this. Okay, so I would choose this one as my x2 t2. Okay, so normally x2 t2 means the final position and final time. Okay, so the later one is the final. Okay, so as the bicyclist is following this path, okay, so this will be the final and this will be the initial. Okay, so the initial time is x1 t1, initial point is x1 t1, x2 t2, the final position and time is x2 t2. Okay, so this is okay, now this is 3. Okay, so x1 is 100 meter. Okay, so you see that this is 100 meter and x2 is 0. So 0 minus 100, and t2 is 40 and t1 is 30. Okay, so it is minus 100 divided by 10. So the answer is minus 10 meter per second. Okay, so the velocity for the third line is minus 10 meter per second because it is the slope of this line. Okay, so basically that's it for this this lecture and also for this chapter. Next we are going to start chapter 3, and chapter 3 is about the kinematics in 2 dimension. Okay, so next chapter I will be talking about the theory part of kinematic in 2 dimension, and then some problem. Okay. All right.